So in this video, we're going to talk about queues, what they are, and we'll see some examples of how they work. We're not going to focus on implementation yet. That'll come in future videos. So a queue is a collection where the first item added to the collection is the first item that gets removed. We remove elements in the order they were added to the collection. And queues are pretty familiar. So here's one example. If you've ever waited in line, then you've been in an actual real-life queue. If you create a playlist, that playlist is a queue. Unless you do shuffle, which throws things off. But let's assume we're just going to play from the start all the way through the end. We call a queue a FIFO structure because the first element that's added is the first one removed. First in, first out. That's as opposed to a stack, which is a LIFO structure, last in, first out. Queues are FIFO, first in, first out. So here we have a linear collection. What would make this linear collection a queue? Well, first off, we would add things to the rear of the queue. Then we remove them from the front. We add them to one end and remove them from the opposite end. Again, in contrast to stacks, where we add and remove from the same end of the collection. We call the add method for a queue enqueue. So we say that we enqueue elements to the queue when we're adding things to the queue. So let's see some examples of how that works. We're going to add 4, 8, 15, 16, 23, and 42 to our queue. So where's our queue? Well, it's right down here. There's our empty queue. The front and the rear both point to that empty location. There's nothing there. So the first thing we add will go to that first spot in the queue. So that'll be 4. So we add 4. And now notice the front stays the same, but the rear moves to the end of the queue. So when we add 8, it gets added at the end. We add 15, 16, 23, and then finally we add 42. So far, none of this is different really from a stack other than we did rotate the queue 90 degrees from where we had the stack. But ultimately, after we add those 6 numbers, they pretty much look the same. However, where it becomes different is when we start removing from the queue. So we call the remove method dequeue, and we say that we dequeue elements from the queue. So here's the queue we had before. Now let's remove the first element, which was 4. So we pull off that element because, again, we may want to use it. We store them in collections because we want to use them later. So it makes sense to pull that off first. Then we remove that element, and notice we move everything now one spot forward. Now, to be clear, our implementation may just move the front to the next spot. We don't necessarily move every element each time. That could be inefficient. But conceptually, that's what happens. Everything moves up one position in the queue. So let's dequeue again. We pull the 8 off the front of the queue, and then we eliminate that location. And now you'll notice everything moves forward one space again. So at this point, it's going to look very different from the stack after we added the 6 elements and removed 2. And it's going to look even more different when we start adding things back. Because if we're going to add 4 and 21 to this queue, we're going to add 4 first at the end. Then we add 21 again at the end, giving us this queue. So again, a queue is a FIFO structure, first in, first out. You can think of it as being more fair than a stack, although again, they have different applications. But the important part is understanding how these data structures work so that when we start implementing them, the code will make sense.